In today's video, you will learn how a geometric figure is rotated on the coordinate plane. You will also learn how to write the transformation rule or the rotation rule that transforms the preimage to the image. In like manner, you will learn how to graph or draw the image given the preimage and a description of the transformation to take place on the coordinate plane. Finally, I will walk you through in answering sample problems to let you experience how these are analyzed and solved so that you will be able to successfully solve geometry problems similar to this in the future. If your lesson is on rotation, or if you have an assignment on this topic, or if you are preparing for a test in math, or a test in geometry in particular, or you're someone who is interested in learning math, then this video is for you. Let us recall what a rotation is. A rotation is a turn. It is a rigid transformation that turns a two-dimensional geometric figure around a fixed point called the center of rotation. Here, point P is the center of rotation. Before a rotation, we call the figure the preimage, and after the rotation, we call it the image. If the preimage and the image are named using the same set of letters in the English alphabet, like what we have here, the image is the figure with the prime notation. We can represent the rotation that took place with this diagram. In rotation, just like in translation and reflection, the preimage and the image are congruent. That is, the corresponding angles and sides are the same in size. Thus, we can write this congruent statement. The orientation of the image is at times different from the preimage depending on the angle of rotation. This rotation is a clockwise rotation, just like the rotation of the hand of the clock. But rotation can also be counterclockwise as shown here. The convention is, when a rotation is clockwise, it is a negative rotation. When it is counterclockwise, it is a positive rotation. On the coordinate plane, the center of rotation is oftentimes the origin. But other points can also be the center of rotation. This will be indicated in the problem. Another thing to consider with rotation on the coordinate plane is the size of the angle of rotation. Recall that on the coordinate plane, the x and y axes are perpendicular. Hence, each quadrant measures 90 degrees. Half of the right angle is 45 degrees. So a measure of 45-degree rotation is about this size. 1/3 of the right angle is 30 degrees. Here is the approximate size of the angle for a 30-degree rotation. Twice the right angle is 180 degrees. Here, the point rotated 180 degrees counterclockwise. Here, the point rotated 270 degrees counterclockwise. And one complete rotation is 360 degrees. You must be familiar with all these angle measures, learners. Let us put triangle A and H on the coordinate plane. Here, we will examine what happened to the coordinates of the corresponding vertices as triangle A and H is rotated 90 degrees counterclockwise to form triangle A' and prime H'. Look at where point H is before the rotation. Point H is right at 0-degree angle. As we rotate point H 90 degrees counterclockwise, the whole figure will rotate. Do you agree? Since the figure is on the coordinate plane and is on one quadrant, we can as well just rotate the whole quadrant. Let us rotate the whole quadrant 90 degrees counterclockwise and see what will happen. This is now the image after the rotation. Let us continue by writing the coordinates of the corresponding vertices on the diagram. On A, from the preimage, the coordinates are 8, -4. On A prime, the image, the coordinates are 4, 8. On N, the coordinates are 3, -4. And on N prime, the coordinates are 4, 3. On H, the coordinates are 3, 0. And on H prime, the coordinates are 0, 3. On the table are the coordinates of the vertices. Let us examine the changes that took place here. Look at the table, learners. On A, the x-coordinate is 8, whereas the y-coordinate is -4. Look at the coordinates of A prime this time. Here, the coordinate of x is the negative of the y on the preimage, whereas the coordinate of y on A prime is the x on the preimage. These changes are true for all the corresponding points like n and n prime and h prime. From these changes, we can write the transformation rule or the rotation rule for 90 degrees counterclockwise as. This means that in a 90-degree counterclockwise rotation, point xy on the preimage is transformed to -yx on the image. Were you able to get it, learners? Okay, before we go further, let us first recap what we have just learned. First, we have learned that if we have the preimage and we know the rotation that will take place, we can locate, we can graph, and know the orientation of the image. Second, if we know the coordinates of the preimage and the image, we can write the transformation rule for the rotation. Okay, so we move on to the next so we can get as well the transformation rules for the different rotations. Rotating triangle ANH 90 degrees clockwise gives us this. The following are the coordinates of the vertices at both the preimage and the image. For easy analysis, the coordinates of the vertices are listed on the table. From here, we can readily see the changes on the coordinates that took place. On A, the x-coordinate is 8, whereas the y-coordinate is -4. Look at the coordinates of A prime this time, learners. Here, the coordinate of x is the y on the preimage, whereas the coordinate of y on A prime is the negative of x on the preimage. These changes are true for all the corresponding points like n and n prime and h prime. From these changes, we can write the transformation rule for the rotation rule of 90 degrees clockwise as. This means that in a 90-degree clockwise rotation, any point xy on the preimage will be transformed to y -x on the image. The negative sign before 90 degrees indicates that the rotation is clockwise. Rotating triangle ANH 180 degrees counterclockwise gives us this. Here are the coordinates of the vertices. A list of the coordinates of the vertices is on the table. From the table, we can clearly examine the changes that took place as triangle ANH, the preimage, is mapped to triangle A prime and prime H prime, the image. On A, the x-coordinate is 8, whereas the y-coordinate is -4. On A prime, the coordinate of x is the negative of x on the preimage, whereas the coordinate of y on A prime is the negative of y on the preimage. These changes are true for all the corresponding points like n and n prime and h prime. From these changes, we can write the transformation rule or the rotation rule for 180 degrees counterclockwise as. This means that in 180 degrees counterclockwise rotation, any point xy on the preimage will be transformed to -x, -y on the image. Okay, let us rotate this time triangle A and H with an angle of 180 degrees clockwise and see what will happen. This is where triangle A prime and prime H prime is now located after the rotation. Let us again label the coordinates of the vertices so we can write the transformation rule or the rotation rule for this type of rotation. The table lists the coordinates of both the preimage and the image for the 180 degrees clockwise rotation that just took place. On A, the x-coordinate is 8, whereas the y-coordinate is -4. On A prime this time, the coordinate of x is the negative of x on the preimage, whereas the coordinate of y on A prime is the negative of y on the preimage. These changes are true for all the corresponding points like n and n prime and h prime. From these changes, we can write the transformation rule or the rotation rule for 180 degrees clockwise as. Learner, how will you compare this rotation rule with that of the 180 degrees counterclockwise rotation rule? You are correct. They are the same. Let us now rotate triangle ANH 270 degrees counterclockwise. After the rotation, this is where triangle A prime and prime H prime, the image is located. Here are the coordinates of the vertices for both the preimage and the image. For easy analysis, the coordinates of the vertices are listed on the table. From here, we can readily see the changes on the coordinates that took place as triangle ANH, the preimage, is mapped to triangle A prime and prime H prime, the image. On A, the x-coordinate is 8, whereas the y-coordinate is -4. On A prime this time, the coordinate of x is the y on the preimage, whereas the coordinate of y on A prime is the negative of x on the preimage. These changes are true for all the corresponding points like n and n prime and h prime. From these changes, we can write the transformation rule or the rotation rule for 270 degrees counterclockwise as. This means that in a 270 degree counterclockwise rotation, any point xy on the preimage will be transformed to y -x on the image. Rotating triangle ANH 270 degrees clockwise gives us this. We get the coordinates of the corresponding vertices, so we can write the transformation rule or the rotation rule for this type of rotation. The table here contains a list of the coordinates of the vertices. From here, we can see the changes on the coordinates that took place as triangle A and H, the preimage, is mapped to triangle A prime and prime H prime, the image. On A, the x-coordinate is 8, whereas the y-coordinate is -4. On A prime this time, the coordinate of x is the negative of y on the preimage, whereas the coordinate of y on A prime is the x on the preimage. These changes are true for all the corresponding points like n and n prime and h prime. From these changes, we can write the transformation rule or the rotation rule for 270 degrees clockwise as. This means that in a 270 degrees clockwise rotation, any point xy on the preimage will be transformed to -yx on the image. Do not forget this, learners. The negative sign just before the angle measure indicates that the rotation is clockwise. Now for a 360-degree counterclockwise rotation, where do you think will the image be located after the rotation, learners? Okay, let us do the 360 degrees counterclockwise rotation on triangle A and H for us to know where its location will be after the rotation. Let's go. There you are, learners. The image is located where the preimage was before the rotation. So for the 360-degree counterclockwise rotation, this is the rotation rule. You will notice that the point xy on the preimage is still xy on the image. This is because after the rotation, the image landed on where the preimage was before the rotation. Thus we say that the preimage and the image are on the same location. Learners, this is also true for a 360 degrees clockwise rotation. The preimage and the image will be on the same location as well. Here is a list of the rotation rules that we got for the different types of rotations centered at the origin. CCW here stands for counterclockwise rotation, while CW is for clockwise rotation. In some texts, R is used to denote rotation instead of CCW or CW. The R with a positive angle means a counterclockwise rotation, and the R with a negative angle means a clockwise rotation. The next table uses this notation in representing the same rules. You have to be familiar with these, learners, because some texts use this notation. There you are, learners. We have laid down the important concepts that you need to know to be able to answer simple problems on rotation. Let us do this sample problem to check our understanding of the concepts. Here is the problem. Sample problem 1. Triangle NDC, shown in the coordinate plane, is rotated 90 degrees clockwise about the origin to form triangle N prime, D prime, C prime. Select the correct orientation of triangle N prime, D prime, C prime, then draw it on the coordinate plane. The options for the first questions are here. Okay, so we begin by reading the whole problem and may read it several times when needed to know what we are looking for, to determine what are given, and to figure out how the given information help find what we are looking for. What are we looking for here, learners? There are two things that we're looking for here. First, we have to select the correct orientation of triangle N prime, D prime, C prime from the given options. Second, we are to draw the image on the coordinate plane. An illustration is given. What strategy would you use to answer this problem, learners? Take note that we are just going to determine the orientation of the image. So the best thing to do is to rotate the quadrant where the image is 90 degrees clockwise like this. There you are, learners. Here's triangle N prime, D prime, C prime. Okay, with this, we can now answer the first question, right? Which is the correct orientation of triangle N prime, D prime, C prime? Is it option A? Is it option B? Option C? Or is it option D? There you are. It is option C. Because we have done the rotation of triangle NDC to form triangle N prime, D prime, C prime on the coordinate plane, we have also answered the second question. Did you realize that, learners? Here's the graph of triangle N prime, D prime, C prime, the image with the preimage. And here are the coordinates of the vertices of the preimage and the image. Okay, so what are our answers again? For the first question, the answer is option C. For the second question, the answer is the graph of the image. Okay, so we are done with that problem. Now, how about if we rotate triangle NDC 90 degrees counterclockwise? At what quadrant will triangle N prime, D prime, C prime be located? Remember the technique that we did earlier. So instead of just rotating triangle NDC, we will rotate the whole quadrant where the triangle NDC is located. Let's go. There you are, learners. Here's triangle N prime, D prime, C prime. The image is located on the second quadrant. That was easy, right? Let us do sample problem 2. Here's the problem. Triangle MHN has vertices at M12, H46, and N42 in the coordinate plane. The triangle will be rotated 90 degrees counterclockwise about the origin to form triangle M prime, H prime, N prime. What are the vertices of triangle M prime, H prime, N prime? Option A, M prime is -2, 1. H prime is 6, -4. N prime is 2, -4. Option B, M prime is 1, -2. H prime is -6, 4. N prime is -2, -4. Option C, M prime is -2, -1. H prime is 4, 6. N prime is -2, 4. Option D, M prime is -2, 1. H prime is -6, 4. N prime is -2, 4. As usual, we begin by reading the whole problem and may read it several times when needed to know what we are looking for, to determine what are given, and to figure out how the given information help find what we are looking for. What are we looking for here, learners? Here, we are to determine the vertices of triangle M prime, H prime, N prime. What are given? We are given the coordinates of the vertices of triangle MHN, which are M12, H46, and N42. Okay, what strategy would help us answer this problem, learners? What are given in the problem will help us figure out the best strategy to solve the problem. Here, we are not given an illustration, so we will not go into graphing it. Though we can answer the problem by starting with a drawing, but following that route will take much of our time. We will look for a faster and efficient way of solving it. Do you remember the transformation rule for the 90 degrees counterclockwise rotation? Here's again the rule. The rule states that the xy on the preimage is transformed to negative yx on the image. That is what we will use here. Okay, we begin by writing the coordinates of the vertices of the preimage. Then we apply the rule. Then write the coordinates of the vertices of the image. Let's go. On M, we have 1, 2. Applying the rule, the x-coordinate of M prime will now be negative 2, while the y-coordinate on M prime will now be 1. On H, we have 4, 6. Applying the rule, the x-coordinate of H prime will now be negative 6, while the y-coordinate of H prime will now be 4. On N, we have 4, 2. Applying the rule, the x-coordinate of N prime will now be negative 2, while the y-coordinate of N prime will now be 4. Now, we can answer the problem. Which of the options is the correct answer, learners? Is it option A? Look at it carefully. So, no. Is it option B? Check the coordinates. Again, no. Is it option C? Check the coordinates of the vertices carefully. Again, no. Is it option D? Look at the vertices carefully again. Oh, yes, option D is the correct answer. There you are, learners. That was easy, right? Okay, learners, everything that we discussed were rotations about the origin. How about if the center of rotation is not the origin? How are we going to do it? Okay, in such a case, the first thing to do is to identify the center of rotation. Let us do the next sample problem so you will know how this is done. Here's the problem. Pentagon HJLNR will be rotated 90 degrees clockwise about 0.11 to form pentagon H prime, J prime, L prime, N prime, R prime. Draw the graph of pentagon H prime, J prime, L prime, N prime, R prime after the transformation. A figure is given. Again, we begin by reading the whole problem and may read it several times when needed to know what we are looking for, to determine what are given, and to figure out how the given information help find what we are looking for. What are we looking for, learners? You are correct. We are to graph pentagon H prime, J prime, L prime, N prime, R prime after pentagon H, J, L, and R is rotated 90 degrees clockwise about the point 11. What are given here? That a rotation of 90 degrees clockwise on pentagon H, J, L, and R is to take place about the point 11 to form pentagon H prime, J prime, L prime, N prime, R prime. An illustration is given. Okay, so where do we start? As mentioned earlier, the first step is to identify the center of rotation. Mark it and write its coordinate. Let's do it. Then, draw perpendicular lines with the point of intersection at the center of rotation like this. If possible, have at least a vertex point of the preimage on one of the perpendicular lines. Here, vertex point H and vertex point R are on the line. Next, assume that the lines you have just drawn are now the lines that divide the whole space into 4 quadrants. The preimage that we have here is located on the first quadrant of the newly divided space. Can you follow, learners? We now rotate the quadrant where pentagon H, J, L, and R is 90 degrees clockwise, about 1, 1 like this. Bingo! Here is now our answer, the graph of pentagon H prime, J prime, L prime, N prime, R prime. There you are, learners. I hope you acquired lots of learnings in this video. Okay, let us summarize what we have learned in today's video. We have learned that, first, a rotation is a turn. It is a rigid transformation that turns a two-dimensional geometric figure around a fixed point called the center of rotation. Second, in rotation, the preimage and the image are congruent. That is, the corresponding angle and sides are the same in size. Third, after a rotation, the orientation of the image is at times different from the preimage depending on the angle of rotation. Fourth, the following are the rotation rules for the different rotations centered at the origin, where CCW stands for counterclockwise rotation and CW stands for clockwise rotation. Another way of presenting the same rotation rules is shown here, where R with a positive angle is a counterclockwise rotation, while R with a negative angle is a clockwise rotation. Fifth, the preimage and the description of the rotation to take place will help determine the orientation, the coordinates of the vertices, the location, and the graph of the image. Sixth, the coordinates of the preimage and the image will help determine the rotation rule. Seventh, when the center of rotation is not the origin, one way by which you can locate the image is by doing the following. A, identify the center of rotation. B, draw perpendicular lines with the point of intersection at the center of rotation. C, assume that the lines you have drawn are now the lines that divide the space into 4 quadrants. D, rotate the quadrant where the preimage is about the center of rotation for the given rotation. Eighth, when solving a problem, you must read it and may read it several times to know what we are looking for, what information are given, and to figure out how the information can help solve the problem. Ninth, when a figure is given, make use of it. It is there to help you analyze the problem. There you are, learners. Hope this video helps. That's it for now. If you have any question, leave a comment below, and do not forget to like, subscribe, and share this video to your peers so others will learn too. Bye.